So, hello guys. Let us start with the remaining portion today. Now, equation 5.0 is the mathematical form expression of Charles law. So, if in exam they ask you what is the mathematical form of Charles law, then you must many people will think that uh, once again, many people will think that the proportional one thing is the equation. Like what does Charles law state? Charles law 1, if it is Charles law 1, then volume is directly proportional to temperature, right? But this is not the equation. This is not the equation. This is just the relation. If they ask a relation, what is the relation which you get from Charles law, then you must write this. But if they ask equation, then you must write V equal to KT. K represents constant, T represents temperature, right? With stated pressure remaining constant, the volume of a fixed mass of gas is directly proportional to its absolute temperature, right? And one very important thing, I think I said it in the last video also. It is very important to convert degrees Celsius to Kelvin, because our chemistry for relations won't work if they are not converted into Kelvin, and this will make your answer go wrong, right? So Charles found that for all gases at a given pressure, graph volume V as temperature in Celsius is a straight line. Volume versus temperature is a straight line. On extending the to zero volume, each line intercepts temperature axis at minus 273.15 degrees Celsius. So what they're saying, this actually, this, where is the origin? Yeah, here is the origin. Wait, sorry, here is the origin. And now if you take these lines backward, then they will meet at a point this. The reason for meeting at this point is absolute zero. Minus 273 degrees Celsius or 0 Kelvin is also called absolute zero. Absolute zero. Here the molecular speed of molecular movement, intermolecular movement and forces, they all get ceased. There's no movement in gases, right? Uh, each line intercepts the axis at minus 273 degrees Celsius. Slopes of line obtained at different pressure are different, but at zero volume, all the lines meet temperature axis at minus 273.15 degrees Celsius. Also, yeah, volume also becomes zero for gases at minus 273 Kelvin. This degrees Celsius. Each line of the volume versus temperature is called isobar. Why it is called isobar? You might know that isobar are those where isobar. What is isobar? Isotope and isobar. So isobar is something when like what do you call it? Atomic mass remains constant, right? Atomic mass, that is for elements. Here pressure. Bar means pressure, right? Hence isobar. So when temperature in volume temperature graph, when pressure remains constant, then that is called isobar. Very important note. Observation of Charles law can be interpreted if we put the values of T in equation 5.6 as minus 273.05 degrees Celsius. We can see that the volume of gas at minus 273 degrees Celsius will be zero. This means that gas will not exist. In fact, all the gases get liquefied before they get to this temperature is reached. The lowest hypothetical or imaginary temperature at which gases are supposed to occupy zero volume is called absolute zero, which I talked about this just now. Absolute zero. This is 0 Kelvin. Okay. All the gases obey Charles' law at very low pressure and high temperature. Okay. What this means that Charles' law also has conditions, right? If they don't lie in this condition, gases won't follow this. All gases obey Charles' law at low pressure and high temperature, right? If there is low pressure, if there is low pressure, then only Charles' law will work. Example: if there is high pressure, then Charles' law will not work. Simple. There's nothing question. You can do it yourself. Questions or mm, on around 2 days from now, I'll be making a video on numericals also, so you can go and watch that. Okay. Gay-Lussac's law: pressure-temperature relationship. Pressure is well defined. One second, sorry. Gay-Lussac's law: pressure-temperature relationship. Uh, Pressure in well-inflated tires or of automobiles is almost constant, but on hot summer day, this increases considerably. So what happens is that I told you already before, right? Pressure is directly proportional to temperature, right? That's the reason why on hot summer day pressure in the tires increases. Tire may burst if not adjusted properly. During winters on cold morning, one may find pressure in the tires of a vehicle decrease considerably. Considerably. The mathematical relationship between pressure and temperature was given by Jos Gay-Lussac, and this is also known as Gay-Lussac's law. It states that at constant volume, pressure of a fixed amount of gas varies directly with temperature. So, it means that when we keep volume constant, pressure of a fixed amount of gas means N constant, amount of gas means N means number of moles, varies directly with the temperature. Then pressure directly varies with temperature. This relationship can be derived from Boyle's law and Charles' law. Pressure versus temperature graph at constant molar volume is uh, each line of its graph is called isochore. Isochore, isochore. You can call whatever, but you must answer it correctly in exam. So when pressure and temperature remains constant, sorry, when pressure and temperature varies at constant molar volume, then the graph is called isochore. And just now I told you about isobar. In isobar also, but in isobar, volume and temperature remains constant, and volume and temperature can vary, and pressure remains constant, right? Now let us go to next page. This, this each line. Please don't think that complete graph. Complete graph, no. Each line is called isochore. Isochore. What he just said over here, right? Each line of its graph is called isochore. Some people might, if they ask how many, maybe they can ask how many isochore are there. So they might write like here how many are there? 1, 2, 3, 4. 4 are there. So they will think that there's one graph, one complete graph, so only one. So they might write one. Right.